press record.
I see.
Okay,
Oh,
well, I got it then.
That's great.
Okay, so welcome. My name is Luke, and the other teacher is Haley. Today we are going to do ciphering, and for those of you guys who don't know what ciphering is, it's basically you get a question. We tell you to start, and you do one question at a time, and then you can only turn your answer in designated intervals, and those intervals are going to be 15 seconds before the end of the minute. So when it's time to turn in your answer, we will call out 15 seconds, which means you can submit your answer. You cannot submit your answer outside of those designated time slots. Okay. After I say minute over, that means that you have to hold on to your answer, and you cannot submit answer until the next 15 minutes section is currently. The scoring is 12 points for the first minute, 8 points for the second minute, and 4 points for the third minute. And I think that's it. We'll do a test run just to make sure everyone knows what to do. But does anyone have any questions for now? I assume not. Okay.
Do you guys have permission? I'm sorry.
How should we do this?
Do you guys have permissions to like send stuff to people in chat? Okay, great. Yay. Okay. Then if you get an answer, you should like private message it to either Luke or I. That's like either one is fine. And then I can either send like a PDF of all of the questions, or I can like pull it up on my screen. So which one?
What if you copy paste it into the chat?
Like the link of all of the problems?
No, like
let's have it screen shared the problems.
Okay, yeah, that works too.
Just so when we have the recording and stuff like that, the people can see it, but
okay. All right, then I guess we'll do like a practice question with question 0.
Sorry, I missed this. Are they submitting their answers to us?
Yeah.
Yeah, in chat, I think.
Okay. You guys can submit it to me too then.
Can everyone see that? Like the question?
I think it's good.
Okay, yay.
I'll time. Should we start? Okay. Question 0, you guys can start. "15 seconds. You can now submit your answers." End of minute 1, you can no longer submit. Okay, wait. Do you guys see question 0 or question 1 on your screens? Question 1, okay. Hailey.
I swear my screen's on question 0. How great. You guys see it like moving right now?
No.
So it's like frozen
Yeah.
on question 1. Wait, let me just try to like re-screen share. This is going really smoothly.
Is anyone feeling like they're in the wrong level? Like you can private message me if you want to go down a level or up a level. In the theta room, they're discussing complex numbers, and the mu room is doing like an introduction to limits. So just let me know.
Can you guys see question 0 now? Okay, yay. Oops, sorry. I guess you guys get a head start in question 1 too.
Okay, well, I guess we should go over question 0. So the question is, what is the period of cosine to the 4th x minus sine of x? So basically, we see that we have a cosine to the 4th x and a sine to the 4th x. And so what we want to do is, let's first factor this and see what happens, okay? So we have cosine to the 4th x minus sine to the 4th x. What we can do is we can factor this using difference of squares. So this becomes cosine squared x minus sine squared x times sine squared x plus cosine squared x. Does anyone know what sine squared x plus cosine squared x becomes? Yes, it becomes 1. So essentially, this is just equal to cosine squared x minus sine squared x. Do you guys know why sine squared x plus cosine squared x equals 1? So basically, we can draw a triangle with hypotenuse of length 1. So if we call this angle theta, cosine of theta is going to be this length right here, and sine of theta would be equal to this length. So since this is a right triangle, we can use Pythagorean's theorem to say that cosine squared theta plus sine squared theta equals 1. And this holds no matter what theta, even if theta is greater than 90 degrees. Is everyone good with that so far? Okay, good. So now we have cosine squared x minus sine squared of x. Now, we can factor this using difference of squares, but that wouldn't really get us anywhere because we just get cosine x plus sine x times cosine x minus x, sine x, sorry. This wouldn't really get us anywhere because we can't easily simplify this, nor can we easily simplify that. Now, turns out cosine squared x minus sine squared x is just equal to cosine of 2 times x. This is a very handy trick in trig questions. And you kind of have to memorize it. Haley, do you know how you can derive it?
Do
Other
you guys
than
know
like through angle addition?
do you guys know what angle addition is, or do you want Luke to teach you guys that? They're basically like a bunch of formulas they have to memorize, but they're pretty useful for alpha.
Alpha Townsend teach. Okay. There's a rigorous proof of cosine angle addition that I saw earlier, but that was like a long time ago. Okay.
Nikolai
Okay.
says cis x, which is pretty good, right? You can do like multiplication of cis and then add.
Oh yeah, yeah. You can do that. You can do cis x. Yeah, that's a good idea. Okay, I found the way to prove it. Let me get some space over here. Okay, so you have a right triangle with hypotenuse 1, right? And then let's call actually sorry, hold on one second. That's not the right visual. You have a oh wait, no, that was right. I'm sorry. So this is a right triangle with hypotenuse of length 1. And let's just draw that line where this angle is alpha and this angle is beta. Okay, this line we can it's probably a bit too long actually. We can connect, oops, that's not good. We can connect it like that and then drop it all the way down. Okay, so basically we know that this is going to be
So can you move the question slightly up? It's like slightly blocking your triangle.
Sorry.
Yeah.
Okay. Okay, we extended this length such that right here is if my pen decides to work. Okay, sorry. This is a right angle. This is just based on our drawing. And so since this is a right angle, we know that this length right here is going to be cosine of beta. And as such, this length right here is going to be cosine alpha times cosine of beta. Does everyone understand so far? Okay. So since this length is cosine alpha times cosine beta, what we now want to do is we want to find this length right here. So if we draw that triangle, we're gonna have something like that, where this is a right angle. And we know that, let's see, we know that this angle is also alpha, because if we do some angle tracing, this is going to be alpha's complement. Therefore, because they're vertical angles, this one is going to be alpha complement, so that's going to be alpha. So we also know that this side length right here is going to be sine of beta, right? Because we know we have this triangle, which is a 1 cosine alpha and sine alpha triangle. And this corresponds with that length. Which means that the altitude is going to be sine alpha times sine beta. Oh, I'm sorry, this was beta. So now we kind of have it all together, right? So if we look at our one big triangle, we have, this is 1, this is alpha plus beta, and we know this entire thing is cosine alpha, cosine beta. And we also know that this length right here is sine alpha, sine beta. So therefore, we can now finally say cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And we have proved the cosine angle addition. Yay. Does that make sense? Because it was really winded. And I don't know what this thing is.
If you're confused, you can probably like Google it still. And there's also like different formulas for like sine addition and sine subtraction and cosine subtraction too. So those, like, you probably need to know those if you want to succeed at alpha. Yep. And they're not that bad to memorize too. Okay, we can probably do question 1 now.
No, we haven't finished the question. So back
you're
back
right.
to the original question, right? We now determined that f of x is equal to cosine of 2x. And now it asks for the period of this function. So let's think about it. What does period actually mean? Well, period just means how long it takes for cosine 2x to go through a cycle. So if we draw cosine of x, it starts at 1 and then goes to 0 at x equals pi over 2, then drops down to -1, comes back up, and then finishes off at 1. This is what we call one period. It's when you go from 1, we call this, what do we call that? We go from one maximum to the other maximum. So what happens if you instead try to graph cosine 2 of x? is instead this period gets smaller. And it turns out, well, if you plug in x equals pi, you will have cosine 2 pi with x equals pi. Which means, and what does cosine 2 pi equal? Well, cosine 2 pi goes back to 1. So therefore, the period is from 0 to pi. In other words, the period is just pi. And there's a neat formula if you guys want to memorize it. So the period of a function, let's say sine of ax, or even cosine of cosine ax, it doesn't matter, is just the period is equal to 2 pi divided by a. And the way you get that is through the same analysis as we did when we determined the period was pi. So in this case, a is 2, so the period is just pi. Does anyone have questions? Okay, I guess we can move on to question 2. Fifteen seconds. End of minute 1, begin minute 2. Fifteen seconds. End of minute 2, begin minute 3. Fifteen seconds remaining in the question. Oh, sorry, end of question.
Okay, yay. Did Luke go like too slow for you guys or like too fast for you guys for the last question? Because I don't really know like how much you guys know. So like, I don't want to explain it too thoroughly or like too unthoroughly.
Have them react using the emojis thing.
Okay. React with a party face if you thought it was too slow, and then like a shocked face if you thought it was too fast.
Okay, a frog.
Yeah, that's something. I don't know what that means. Oh, okay, too fast. You went too fast. Okay.
Frog again. Okay.
Wait, what does the frog mean? Okay. Okay, well, I guess I'll go like kind of slower. I don't know. Okay, so for this kind of question, it's like a conic, right? It tells you it's a conic. So basically what you do is you group all the x terms together and all the y terms together. So like 3x squared minus 12x and then minus 4y squared plus 8y plus 20. So you group them together and then you do something called like completing the square. So you complete the square for this part and this part. So you can factor out a 3, right? And then complete the square. Does everyone know what completing the square is? Because like, yeah, so basically you try to make this thing a square and this thing a square. And then we added 12 here, right? And we subtracted 4 here. So we need to add 12 and subtract 4 on this side. So you get 3 times x minus 2 squared minus 4 times, oh my god, y minus 1 squared equals negative 12, right? And then we want to divide by negative 12 on both sides. This is just like the general form of what you do if you want to graph a conic. And then we get 4 times, or sorry, we get x minus 2. Okay, that's bad, sorry. This is going really smoothly. Okay, so we get y minus 1 squared over 3 minus x minus 2 squared over 4 equals 1. And then we just want to put stuff in this general form to like graph a conic, because we want to see like what the triangle looks like, and also we want to figure out like what the lattice recti or whatever look like. Okay, so using this equation we can graph it. So we can put coordinate axes here, and then this this form is like what the x, like x minus something tells you what the x coordinate of like the center of the graph is. So like it's x minus 2, so the center of the graph has like an x coordinate of 2, and this is y minus 1, so the center of the graph has like a y coordinate of 1. Like the center of the graph is here at 2, 1. And then these things in the denominator tell you like how wide like the things are, like the sides are before it becomes a conic. And if it's a minus sign here, that means it's a hyperbola, and if it's a plus sign, it means it's an ellipse. So the 3 is under the y here, so it means we go up square root of this number here. This is like kind of hard to explain, but it's like here and here for the vertices of the hyperbola. So it basically looks like this. So we want the area of the triangle formed by both of the foci. So the foci are these 2 points, and they basically define the hyperbola, but we won't get into that. But anyways, the distance from the foci to the center is c squared. In a hyperbola, c squared equals a squared plus b squared, where a and b are these 2 numbers. So a squared is this in this equation, and b squared equals this. And that's also how we got like the root 3 over here, because that's how we get like the vertices, we add a to the y coordinate because the y is the positive side. Anyways, so c squared equals 7 in this case. So that means this distance is root 7 and this distance is root 7. And then the latus recti are like 2 points on the hyperbola such that when you draw like the line between them, it goes to the focus. And like the length of the lattice rectum is 2b squared over a, where b is like the stuff over here still. So a squared is still this and b squared is still this. So 2b squared over a is 2 times 4 over root 3, right? But we want the area of the triangle. Sorry, this is really messy. But if we have this thing, we want the area of the triangle that's like this, right? So we know this length is 2 root 7. And then we want only 1/2 of the lattice rectum. So 1/2 of the lattice rectum is 4 over root 3, right? And then we can do 1/2 base times height. So root 7 times 4 over root 3, which is 4 root 21 over 3. Yeah, sorry, that's a lot of stuff. Okay, conics are kind of hard to teach by like one question. I think it's best to learn conics by actually like doing multiple conics questions and like researching into like each of the conics. So like research into like hyperbolas, ellipses, circles, parabolas, etc. If you want to learn about this. Yeah. Okay, does anyone have any questions? Oh, I think it's 4 square root of 21 over 3. If I didn't mess up with my arithmetic. Wait, let me just check the solutions. That seems like a better idea. Like, oh, it's fine. If you get a different answer and you're sure it's like right, I probably did something wrong with my arithmetic. Okay, anyways, we're gonna move on to question 2 now.
Okay, question 2. I'll pull it up. Begin. Fifteen seconds. End of minute 1, begin minute 2. Fifteen seconds left in minute 2. End of minute 2, begin minute 3. 15 seconds left in the question. And time.
Okay. Yes, so this is like not specific to alpha. This is like counting in general. So when we do counting, we want to not list everything out because that's really not a great idea. Instead, we want to like organize it. So if we make a mistake, we can check our work easily. So how many odd numbers between 550 and 800 can be formed using only the digits, blah, blah, blah. Okay, so we noticed that like 550 is kind of special because we can't have like 547 as one of the numbers. So like there's more restriction on this digit. So let's split it into a separate case. So let's do 500 to 600 as like, sorry, 500 to 599 as one case. And then like 600 to 799 is one case. Because we noticed that like this is slightly different. So for the case with 550 to 599, we only have like one choice for this first hundreds digit because it can only be 5. For the second digit, it has to be 5, 6, 7, 8, or 9, which is 5 choices, right? And then for the third digit, it has to be odd. So it can be 5, 7, or 9. So that's 3 choices. That's 15. Also, like I was kind of confused on this question because I thought like you couldn't use digits more than once, but like it doesn't say that. So I think you can use digits more than once. Maybe we can do it both ways. I don't know. And then for the second case, for the units digit, there's 2 choices. I mean, not the units digit. For the hundreds digit, there's 2 choices because it can be 6 or 7, right? And then for the tens digit, it can be any of these, right? Because there's no restriction on that. And then for the last one, it has to be odd. So it's 5, 7, or 9. So that's 3. So that's total of 36. And then we add them up and that's 51. Yeah, I think it could be interpreted as like you can only use each digit once. But if that were the case, we could just like do the same thing, except say we already used one digit for the middle digit. So we don't have 5 options, we have 4 options. And then we should not do the middle digit first. We should do the last digit first. So for the last digit, we had 2 options, like 7 or 9, right? Because we already used 5 over here. And then we have 6 minus 2 options. So we only have 4 options here because we already used a 5 and like a 7 or a 9. So we only have like 4 options left. So that's 8. And then for this case, we still have 2 options up here, but we have to split, we have to treat 7 or 6 and 7 differently because 7 is odd, right? And because 7 is odd, like when we're considering how many options we have here, I think it's different. I don't know, actually. Okay, anyway, so if we have 6 in the front, in the back 2 digits, we still have 3 options, right? Because it can be 5, 7, or 9. And then for these 4, it has 4 options. And then for the 7 case, we have 1 here, and then we only have 2 options here. And then we have 4 options here. So that's 12, and that's 8. So if you did it like, you can repeat digits, it's 51. And if you did it like you can not repeat digits, it should be 28, unless I messed up, which is possible. Yep, that's how you do it. So basically split it up and consider different cases and then add the cases up. Are there any questions? Okay, I guess we can move on.
Question 3. Ready? begin. Fifteen seconds. End of minute 1, begin minute 2. Fifteen seconds in minute 2. End of minute 2, begin minute 3. Uh, 15 seconds left in minute 3. And time. Okay, so we have this question. Now, this is pretty complicated, so let's try to unravel it bit by bit, okay? So, first off, we're taking the cosine of 2 times arc sine of negative 1/6. The key for this question is to create a visual. So, for example, it's hard to take the cosine of 2 times the arc sine. So let's draw it real quick. So what is arc sine of negative 1/6? What do you guys know what arc sine means? Inverse of the sine function. Okay, great. So the arc sine is like he said, the inverse of the sine function. So what does the arc sine output? In other words, what's the what does it output? Okay. Arc sine outputs an angle, right? Because what's the domain of sine, the sine function? Well, it's just an angle, right? So arc sine, since it's the inverse of the sine function, the input or the domain is, oh, sorry, wait. The input is a real number and the output is the angle. So what in this case, let's look at arc sine of -1/6. So that just means that if we have a right triangle, if we call arc sine, oh, not -1/6, sorry. If we call that x, then this is going to be x, where this is 1 and that's 6. Oh, sorry, -1/6. If it was -1/6, then this would just equal to -x, as this triangle is now turned into this triangle, where this is x. And you'll learn later down the line why this triangle is not equal to this one. Oh, not, sorry. You'll learn later on why this triangle can't be in the third quadrant, where despite this length being -1 and this length being 6, you'll learn later on why this isn't part of arc sine's domain. So this is our triangle right here. It's this one. Now, if we were to take the cosine of this, ignoring the 2, first off, we can use Pythagorean theorem to quickly solve for this side, right? It's just equal to square root of 36 minus 1, or root 35. So that means the cosine of arc sine of -1/6 is just equal to adjacent divided by hypotenuse, which is square root of 35 over 6. The issue with this is that the question doesn't say cosine of the arc sine of -1/6. Instead, what it says is, why can't I move this? Okay. Instead, what it says is cosine of 2 times the arc sine. Now, we can do what we learned in question 0, which is cosine of 2x is just equal to cosine squared x minus sine squared of x. Does everyone remember that? And again, you can get this by using cosine angle addition. I don't know what is going on with my lighting. Okay, so knowing that, we can plug in arc sine of -1/6 for x. So what we get now is cosine squared of arc sine of -1/6, and we know this is equal to root 35 over 6 squared minus sine squared of arc sine of -1/6. And well, that's just -1/6 squared. And therefore, we get 34 over 36, or 17/18. So that is the answer to the first part of the question. We still have a second part to deal with. Now, the second part says tangent of arc secant of -13 over 12. So tangent of arc secant -13/12. So once again, we can draw the picture, right? However, this time we have a triangle where the adjacent is -12 and the hypotenuse is 13, right? Is that right? Yeah. So this is just equal to x is equal to this thing. So if we want to take the tangent of that, well, tangent is just opposite over adjacent, right? So this is a 5, 12, 13 triangle, which means the tangent is just going to be equal to -5 twelfths. Make sure you guys get the signs correct because that trips up a lot of people. So if we combine that with our answer to the previous part, we have 17/18 minus 5/12. And this is just equal to 34 minus 15 all over 36, or just simply 19 over 36. Does everyone understand that? You guys will learn more about it throughout the year. So if you don't fully understand it, it's fine. But I just want you guys to understand the overall like gist of the question. Okay, I'm assuming there aren't any questions. So, let me pull up the next question. Begin. Fifteen seconds left. End of minute 1, begin minute 2. Fifteen seconds left in minute 2. End of minute 2, begin minute 3. 15 seconds left in the question. End of the question.
Okay. So this is like also not super alpha-y, because the thing about alpha is that it's like 80% theta, so that's great. So we need to factor this, right? We need to like simplify this. So basically we look at the top, and this looks like we have a square here, we have a square here. So it looks like difference of squares. So we can have 3 squared minus c squared minus 9 squared minus 6c squared, because I just put the 4 in, because 4 equals 2 squared. So I just put it in. And then that is a squared minus c squared minus 9 plus 6c, and a squared minus c squared minus 9 minus 6c, right? And then the denominator, we can notice also some more square stuff. So a squared minus 6a plus 9 is equal to a minus 3 squared, right? So we can write this bottom term as a minus 3 squared minus c squared. And then for this other, let's just leave it as is for now, and then we can figure out what to do with it later. Okay, and then we look up here and we see these 3 terms, right? And then we can factor out the negative sign. So we get c squared plus 6c plus 9, right? And that is minus c plus 3 squared, right? So let's replace that with minus c plus 3 squared. And we look over here and we see we can do the same thing with these 3 terms, right? So we have minus c squared minus 6c plus 9. So we can replace this part with minus c minus 3 squared, right? And then we have more difference of squares up here, right? This is like really bashy, kind of annoying. It's okay. We have a minus c plus 3, a plus c minus 3, a minus c minus 3, and then a plus c plus 3. And then on the bottom, we can do difference of squares on this one still. So it's a minus 3 minus c and a minus 3 plus c. And then on this bottom part, let's see if we can do anything. A squared minus c squared, we can write as a minus c times a plus c, right? So, and then 3 times a plus c is also equal to 3 times a plus c, right? So we can just do a plus c, factor out the a plus c from both of these terms, and then we get a minus c plus 3 remaining left over. So now we can cancel out stuff. So this is the same as this. This is the same as this. This is the same as this. So we're left with a plus c plus 3 over a plus c. So yeah, just keep on bashing out this difference of squares. That's it. Okay, we can move to the next question.
Oops. Okay, question 5 begin.
15 seconds. Second minute.
Haley, what question are you guys on?
5, I think.
Okay. If you're tired after this, I'm happy to take over. And Jesse is here, so you can just like give us the links and we can take over. Unless you want the full X hours of service. I'll give you
15 seconds.
2 hours, 2.5 hours.
Third minute. Fifteen seconds. Time.
Okay. All right, so we have this question. Isosceles triangle has a perimeter of 50. And the sum of the lengths of the base and the height is 31. So we can start off by labeling some sides, right? Let's call this side length x. And since it's isosceles, this one must also be x. And the perimeter is 50. So that means the length of the entire base is going to be 50 minus 2x. So if the length of the base is 50 minus 2x, then the length of this side is going to be 25 minus x because it splits the base in half. Now we also know that the sum of the length of the base and the height is 31. So if we call this like z, for example, then we know that 25 minus x plus z equals 31. If we solve for z, we get z equals 6 plus x. And now we can just use the Pythagorean theorem, right? We have a right triangle with a hypotenuse of length x, a base of length 25 minus x, and a height of 6 plus x. So the only good way to do this is just by foiling it all out, or you can guess and check. Wait, no, this is not right. Oh, sorry. It said the sum of the length of the base and the height is 31. So the height is actually not 6 plus x. Because it says the length of the base, 50 minus 2x plus z equals 31. So therefore, Z is just 2x minus 19. So if we expand it all out, 25 squared is 625 minus 50x plus x squared equals 4, oh, sorry, plus 4x squared minus 76x plus 361. Yeah. And we can cancel out an x squared. We can combine the two constants, giving us 986. We have a 4x squared. We can combine the linear terms, which gives us minus 126x. And finally, the quadratic term. So we know we have this quadratic. One thing we can do is we can divide out a 2. We might even be able to divide, no, we can't divide out a 4. So if we divide out a 2, we get 2x squared minus 63x plus 493 equals 0. Seeing that the linear term is 63, which is rather small compared to 493, we know that the two values of x must be somewhat close together. And so if we try to prime factorize 493, we get, sorry, that was my watch. We get, let's see. We get 17 and 29. Okay, so how do we combine 17 and 29 to get a sum of 63? Well, if we multiply the 17 by 2, we get 34. 34 plus 29 is 23. So therefore, this factors to 2x minus 29 times x minus 17. Meaning the two values for our legs are either 29 over 2 or 17. Now, does the question... Okay, the question asks for the sum of all possible values for the height. Just a quick verification, make sure triangle inequality holds. If x is 17, then that means the base is going to be 16, so that works. If the legs are 29 over 2, that means the base is going to have length 21, and that satisfies triangle inequality. So therefore, our answer is 29 over 2 plus 17, which is equal to 68 over, no, that's not right. Sorry. For 63 over 2. If I did my math right. Okay.
X value of the height.
I'm sorry?
Aren't those the values of X, not the values of Z?
Does that ask for... Oh, oops, my bad. Okay, yeah, good catch. So we're actually looking for Z. So it probably would have been a better idea to start labeling this as X. But we can quickly solve it through some more Pythagorean theorem. So if this side length is 29/2. This side length is going to be 21/2. And that looks like a Pythagorean triple. Is it 10? Let's see.
Yeah, we have the equation that z equals 2x minus 19.
Yeah, okay. This is 10. Keep going.
Oh, no, I'm just saying that like we already established z equals 2x minus 19. We can just use that.
Oh, yeah, that's true. Yeah, okay. So our two values are 10 and what is it? 34 minus 19, 15. So our answer is 25. Good catch. Is everyone okay with that problem? It was slightly winded, but okay. If no one has any questions, we can move on to question number 8. Or sorry, I can't add. Question number 6. Begin. Oh, that's not the full question. Sorry. Okay, now you can begin.
Second minute.
Sorry, 15 seconds.
Third minute. Fifteen seconds.
And time. Okay, so Haley, do you want to do this question?
Sure. Okay. So for this question, you have to do something called row operations, or I guess column operations. So basically, to find the determinant of a 4x4, you kind of have to do minors, I think. So basically, minors is you take like a random number, like let's say you take 5, and then you multiply it by the determinant of what's remained, like what's left behind when you cross out the row and the column that that number is in. So the minor of like this element would be 5 times this. And you guys all know how to do 3x3 determinants, right? It's like appeared in theta. Okay, anyways, so basically what we want to do is we want to make a bunch of zeros, because when we find the determinant using minors, all we have to do is we have to take the minor of each element in a certain row or column and then add it all up. So we want to have the most number of zeros possible so that when we add it up, it's like we don't have to add that much stuff up. So we can do a column operation to make this a 0, because we notice that there's 2 zeros here. So if we multiply everything in the first column by 2 and add it over, we have -1, 5, 0, and 10, right? And then this remains the same. So like the one that you're multiplying and adding by stays the same. I hope I copied that down right. Okay, and then now we can just do minors on this element, because everything else in its row is 0. And so we do 1 times the leftover elements, which is 2, 3, -1, 3, 4, 5, and 1, 3, 10. And then in this case, the 1 is positive because we look at the sum of like its row number and column number. So this is 1, like 2, 3, 4. This is 1, 2, 3, 4. We look at the sum of its row and column number and we notice that it's even, so we don't negate it. But if it was odd, we need to negate this. And then we can just do minors again on this one. So 2 times the determinant of this smaller one, which is 25, and then -3, because this is like minus because the sum of the row number and the column number is odd. So it's -3 times 25, and then it's -1 times 5. So we get 50 minus 75 minus 5, and that's -30. Yes. Unless I did something wrong, which is very likely. But yeah. Oh, I did something wrong. What did I do wrong? Yeah, looks right to me. It's probably right. Okay.
Wait, Haley. Someone said you wrote 0 instead of -2 for the third row. Oh wait, no. She added twice the first column to the last column, so you get 2 plus -2, and you get 0 for that.
Yeah, I was trying to make zeros in that column. So yeah. Okay, I'm just gonna say I'm right and the answer key is wrong.
Okay, but do you guys understand how she got the matrix and then changed that matrix into a 3x3 matrix?
The solution looks right too. I don't know what's wrong.
It's probably
Oh,
an
whatever.
arithmetic mistake. It's fine.
Yeah.
But the key in this question is to try to create a 3x3 and then go from there.
Mhm.
Okay. Next question. Begin.
Fifteen seconds. Second minute. Fifteen seconds. Third minute. Fifteen seconds. Time.
Okay. So, 3 dice are thrown. What is the probability that two or more of the dice show the same number? Okay. So let's visualize 3 dice. Um, let's say, for example, first off, there are 3 choose 2 ways to pick which 2 die. Oh, okay, sorry. Let's break it up into cases for this question. Okay, so let's say first case number 1 is 2 of them show same number. Okay. So for this one, you have 3 choose 2 ways to pick which dies show the same one. And the first die can be anything. The second die, well, it has to show the same number, right? So that occurs with a 1/6 probability. And then the third die, well, it can't be the same number as the other two. So it has to be anything but that one number, which means there's a 5/6 probability. So that's case 1. Case 2 is when 3 of them show the same number. And, well, there are 3 choose 3 ways of selecting which dies have the same numbers. And the first one can be anything. But the second and third one, they both have to be the same number. So that means they both have a 1/6 probability of becoming the same number. So if we look at our two cases, all we have to do is just add the result up. So we have 3 times 5/36 plus 1 times 1 times 1, or 1/36. So 3 times 5 is 15, plus 1 is 16. 16/36 equals 4/9, giving us our final answer. Does anyone have any questions? If not, we can move on to the, you can also do complementary counting. Yes, you can. But it doesn't really matter because there's the same number of cases each way. For example, if you did complementary counting, you would have to think about the, okay, wait, hold on. Oh, huh. That's pretty cool. Okay, so what Jesse said was, you can do complementary counting, and the way you do that is you, sorry, you start off with your two cases being, it has either one of them, well, all of them show different. Wait, hold on, I'm sorry. Oh, that's true. Okay, so what Jesse said was, if you want to do complementary counting, you actually only have to think about one case, which is all of them show different numbers. And there's only one case, so actually complementary counting is much faster than this. So if you would do it that way, then you'd have to start off with, of course, 1 minus the entire thing, 1 minus, and then if you want them to have different numbers, then it's just 6 times 6 choose 3, all divided by 216. Wait, is that right? Yes, because okay, because if you have your 3 dice right here, the first one can have 6 numbers, second one can have 5, and the third one can have 4. So this is just 1 minus 6 times 5 times 4. And that's 1 minus 20/6 36. So you still get the same result in the end, 4/9. Any questions? That was really smart. I didn't think of that. In fact, Jesse, do you want to teach now?
Yeah, we're good to take over. You're on the 20. Okay, he has the cool setup. I can just do the timing. Excellent. Okay, great. Hailey and Luke, you're free to go or stay or whatever, but Jesse and I can take it from here. Okay.
Okay, my recommendation to you guys is, I don't know if you've done this already, but either like pin me or Himal so we're big on your screen. Whoever's like talking at the time. That's what we
Yeah.
told the Theta people, and they did it, and it worked. So I recommend alphas do that too.
Okay, excellent. Okay, I'm gonna start the timer.